Hello. Now, we are looking at circles and we're looking at how to find the equations of circles that are tangent to the x or y axis. So what we can see here, if I've looked at my sketches here for the x and the y axis where we're touching or tangent to the y axis, if we start up here with when we're tangent to the y-axis, we know that our center of our circle, if we use the expanded version of our circle equation, is at minus g minus f. Now if I'm tangent to the y-axis, that means my circle is just touching the y-axis and then goes out perpendicularly from the y-axis out to the center of my circle at minus g minus f. Well, minus g is this x coordinate out here, which must be the same as the radius. So the radius then is going to be, modulus here is just so that we don't end up with a negative number for our radius, but it must be the same as the x coordinate of our center. Likewise, we can see from the picture, if we were tangent to the x-axis, the perpendicular to the tangent goes through the center, so our radius here would be going perpendicular to the x-axis. And that means that our distance here must be the same as the value of the y-coordinate of the center of our circle. We're starting at y is 0, and in this case we'd be going down to f. And the distance we must go down to the center of the circle must be the same as f. So or must be the same as f. Our radius of our circle must be the same as the f in our equation. So that is what those are two facts that are very useful for trying to find the equations of circles. But they're only part of solving these problems. It's important to understand that these are normal finding the equations of circles questions. It's just that we have an extra tool that can help speed things up. So that's the key point here. These are normal finding the equations of circles questions. So we're going to try and either use this equation and find three equations in G, F, and C in order to find the equation of our circle, or we can try and solve it geometrically. Now, most of the time, because of this situation here where or is equal to u, the value of g, or is equal to the absolute value of f, it's usually faster to solve a question where you have the circle tangent to the x or y axis using the algebraic method as opposed to the geometric method, but you should be able to solve them either way in almost all cases. So what we're going to do is look at this situation here and how it is we can solve it. So S1 is a tangent to the x-axis, is a circle that is tangent to the x-axis at minus 4, 0, and contains the point at 0, minus 2. That means if I sub in x is 0, y is minus 2 into this equation, the equation must work out. So I can use these two pieces of information to find the equation of S1. And as we're used to at this point, we draw a picture to help us with our intuition. So we know that the tangent to the x-axis is at minus 4, 0, and we know that it contains the point 0, minus 2. So we're on the negative, we're on the negative side here, so we're going to start off with our sketch, and we're going to be involving below the x-axis, or below the x-axis. So we must be dealing with a situation we're crossing through the point 0, minus 2. So we're crossing through that point and we're tangent at minus 4, 0. 1, 2, 3, 4. So we're tangent at this point and we cross through this point. So I can immediately see I've got quite a large circle. I may not be able to draw it in terribly well here, but I'll still get the rough notion of it, which is really all I'm aiming for with my sketch, so that I have a bit of an intuition as to what I'm dealing with. If I'm going through a circle like that, it's a big circle. So I've got something approaching that. That is a very poor circle, so I'm going to see if I can redraw a little bit of that so it doesn't look quite so awful. But all I'm trying to do is develop a little bit of intuition as to what my circle is supposed to look like. Roughly, where is the center supposed to be? Is there anything that jumps out at me about the geometry of the problem that would help me? So I know my center is going to be somewhere down here. Why do I know that? Because the perpendicular, so this is point -4, 0. This is 0, -2. I know that the perpendicular to my tangent goes through the center. So I know if I draw a perpendicular line going down here, I know that my center must be somewhere on that line. So I'm going to draw it in around here. So I know that's the radius of my circle there. I have no idea where this point is just yet, but I know that it's somewhere on this line. I also know the equation of this dashed line that I've just drawn in, because it is going to be the line x is equal to -4. If I have the perpendicular to the x-axis going through -4, what fact describes all of the points that are on my dashed line here? They all have x is equal to -4. So I know that the equation of my dashed line then is x is equal to -4. What else do I know? I know from my arguments up here that my center of my circle is going to be at -g -f. And I know then I have started at y is 0 and I have gone down to -f. So that means that my radius must be equal to the absolute value of the location of my y-coordinate of my center. So I know lots of information now from having drawn in my sketch. I know that the center of my circle contains the point x is equal to -4. And I know that my radius is equal to the absolute value of f, the y-coordinate of my center. So I now know loads of information about my circle. So let's try and put this down into things in practice. Well, I know that if I have a line containing the center of my circle, I could sub in g and f and get a valid equation. So I know that if I have the line x is equal to -4 going through the center, that means that -g -f solves that equation. I can sub in x and y in there. Well, there is no y in this equation, so I just have -g is equal to -4. So g is equal to 4. So very quickly, because I've drawn my sketch, I have g is equal to 4. One of my 3 points is already found. So that means that I know that the center of my circle must be at -4 -f. Very little work done, but because I drew my picture, I now know that. What else do I know if I'm dealing with G, F, and C? It means that I know that the radius is equal to the square root of G squared plus F squared minus C. And I know because of my sketch that OR is equal to the absolute value of minus F, or F. Doesn't really make any difference. Sorry, not squared. I'm going to square it in a second. So I can use this fact to help me find G in terms of C, because I can see when I square both sides, my F's are going to sum to 0. So what does that allow me to do? I can square both sides. And I get G squared plus F squared minus C is equal to F squared. Subtract F squared from both sides. And I actually want C on the other side, so I can get one thing in terms of the other. So G squared is equal to C. And I, in this question, know that G is equal to 4, so I can just sub that in. G is equal to 4. So 4 squared is equal to c. C is equal to 16. So with very little work, because of my equation here and because of my sketch, I'm able to get the values for G and C. So now I need to find the values for F. Well, what other information am I given in the question? I'm given that the circle contains the point 0, minus 2. So let's try that. X squared plus y squared plus 2gx plus 2fy plus c is equal to 0. I know that at g is equal to 4, and I know that c is equal to 16, and I know that the point 0, minus 2 solves the equation, so I can sub in that for x and y. So I get 0 squared plus minus 2 squared plus 2 on 4 on 0 plus 2 on f on minus 2 plus 16 is equal to 0. So I get 4 minus 4f plus 16 is equal to 0. So minus 4f is equal to minus 20. Rearranging, f is equal to 5. So I now know that f is 5, g is 4, and c is equal to 16. I now have all of the things that I need in order to solve my equation. Or I should say, to write down the equation of S1. X squared plus y squared plus 2gx plus 2fy plus c is equal to 0. X squared plus y squared plus 2 on 4x plus 2 on 5y plus 16 is equal to 0. X squared plus y squared plus 8x plus 10y plus 16 is equal to 0. And that is the equation of S1. Now, sometimes we'll be able to do clever substitutions like this, and sometimes we will be in the situation that we often were with finding the equations of circles before, where we had to do simultaneous equations. In this case, we were just able to do substitutions a lot, and that got us out of having to do formal simultaneous equations. But we know how to find the equations of circles already. The only new thing here is that we note the fact that if we are tangent to the x-axis, the radius will be equal to the absolute value of the y-coordinate of the center. And if our circle is tangent to the y-axis, then our radius is going to be equal to the absolute value of the coordinate, the x-coordinate of our center. That's the only new fact that we're dealing with here. Otherwise, this is finding the equations of circles, which we have already gotten very good at. And we know how to do our simultaneous equations, and we know how to approach it geometrically. Just to remind you, the way that we would look at this question geometrically would be, we can look at the tangent and get our x is equal to minus 4 line, like we did here. And then we could get the equation of our chord going through our 2 points. Then get the midpoint of those 2 points, get the midpoint of our chord, and we know the perpendicular bisector of our chord goes through the center. So we get the equation of this line, or a dash grid line here, and where our x is equal to minus 4 line and our perpendicular bisector line crossed each other would give us the center of the circle, and then we would get the distance from the center to our one of our points to get the radius of our circle. So that would be the geometric way of doing this question, but often the algebraic way that we're doing here will be faster when we know this extra fact about or being equal to absolute value of f or being equal to absolute value of g. And that's what we need for now.